Hello, welcome to Matt's Wild About Nature. My name is Matt. Today, we're coming to you from a really cool place. A place that's been around for a very long time. A lot of people like to come here, and there's so much history. So we're going to go digging around through history and carving our way through this video. If you think you know what we're talking about, stick around. So this is the Palo Duro Canyon. I remember in my last video, we were talking about comparing the Palo Duro Canyon to the Grand Canyon. The Palo Duro Canyon is 120 miles long, 20 miles wide at its widest, and 800 feet deep. Now, to show you how deep this canyon is, I'm going to turn the camera around in a little bit and show you a rim and show you how high that is to give you an idea of how deep 800 feet is. But for right now, we're going to talk about this. This is a very eroded part of the Palo Duro Canyon. Now, depending on what timeline you subscribe to, this either happened over millions of years or it happened rather quickly. Maybe a couple years, maybe not even a year. It depends on which one you subscribe to. I personally don't believe in the millions of years, and I'll explain why when I talk about the Grand Canyon. And the Grand Canyon and Palo Duro Canyon explain the same thing with what I'm going to talk to you about. But right now, there are some spots here where you can see layers of sedimentary rock. The bottom one, let's start with the bottom one, it's easier. That is all red, or like a rusty red. Now why do you think it's a rusty red? If you said because there's iron in the soil, you're absolutely right. There's a lot of iron in this soil, and iron corrodes or rusts and turns red. You've seen it before. You leave a tool outside in the rain, or a tin can has been sitting out in the weathering for many years, and it turns that reddish orange rust color. The second layer above it is more of a sandstone. As you can tell, you can see some of the iron, see some of it. Then there's that sandstone up there. The higher you go, you get into thicker and thicker rocks. The iron would be like a base layer. It'd be right where it's closest to the ground. The sandstone would be about in the middle, and the top would be something akin to like a limestone, or not basalt because there isn't any volcanoes around here, but there's a lot of different types of rock that could be in here. Now there are some striations that you can see. You can't see them from here because my camera won't zoom in far enough. But there's some places we might be able to go to be able to see those better. If this looks familiar, it's because this is what we were just looking at just a little bit ago. We were probably half a mile, 3/4 of a mile away, which made it a little bit smaller. It may have even been further than that. I'm not really sure on how to judge distance here. But this is that same rock formation we were looking at before. But now, since we're here, you can see things a little bit clearer. You see all these lines right here. These lines, which I'm going to zoom in so you can see them. These lines are what's called striations. And striations are how geologists determine the age of the Earth in rocks. Now what they say about these striations are that every striation is a different layer in time. So we have more down here, but you can't see it. This first one and that second one are what they say is a striation through time. Now the amount of time, again, depends on the timeline you subscribe to. The amount of time varies between millions of years and only a couple decades. But I believe that this was laid down quickly, not super slow. But either way, the striations at the Grand Canyon, you'll see a whole lot more striations. Part of that is because it's a lot deeper. Also, because the geology is different. The rocks are different. So you're going to have different striations, different colors, different layers between here and the Grand Canyon. So let's go check out more of this canyon. Remember I told you I was going to show you something that gave you an idea of how deep 800 feet is? That rim right there, that's 800 feet up. Now, those trees up there, if they were at the Grand Canyon, you wouldn't be able to see them because the Grand Canyon is almost a mile higher. Those would be tiny little specks. Now, I said in the last, just a little bit ago, I said I don't believe in the long-term, like the long-time erosion story that they have. I believe in a shorter one, and I told you I'd tell you why. Well, if you look at the Grand Canyon, you would say that there's no way the Colorado River could carve that all the way through. Especially because the flow is so small. And I know some people are gonna yell at me and say, Matt, the Colorado River is small now because it's drying up. Yes, I get that. But even at its peak, it was not that wide. Now to carve it the way it is that you say would be very hard to do. The reason why is because there are very wide spaces and there are very narrow spaces. And if you're running the Colorado River at that wide space and you come to a narrow space, what's going to happen is the same thing as you've ever played with fluid dynamics. What I'm saying is, let's say you take a PVC tube and you start it at a 4-inch tube and you step it down until you get a 1/2-inch tube. And then you start pouring water through it. What do you think is going to happen? Well, the water is going to go through the 4-inch tube really quick, but very little pressure. You get down to the 1/2-inch, it's going to go through really, really slow, but have a lot of pressure behind it. That's why I don't believe that it could have happened over millions of years, because that narrow spot wouldn't have existed. Because that water would have come with so much pressure, it would have made everything that wide. And that evidence is not there. It's the same thing here at the Palo Duro Canyon. They say it was a river, the Fox River, that did it. Again, There are too many geological changes to support a wide rushing river carving all of this at the same time. Now you may also say, well, there are places where it kind of levied off, split here, split there. No, I get that. But again, if you were to have a massive amount of water coming through and then you were to fork it off, yeah, you'd have a slower water, but that water wouldn't be enough to erode. So let's keep going. Let's see what else we can find here in the Palo Duro Canyon. Here's another thing that the Palo Duro Canyon and the Grand Canyon, Arizona, have in common. But the ones in the Grand Canyon are much bigger. Caves. Now these are eroded away very shallow. These may have been eroded when the whole canyon was eroded, or they may have been eroded over time from wind and rain and stuff like that. This is all sandstone here, and it erodes rather quickly. Now, it erodes that if you have enough water running through and a torrent enough, you can erode a good decent amount in only a couple of hours. But with the amount of rain that we get here normally, it doesn't erode that fast. It takes a little while. We also have striations. Right next to the caves, we have the striations that you can see. These two are quite close together, so you know there wasn't a lot that happened between there. Now let me ask you again, do you remember what striations are? If you said striations are what geologists use to determine time, you're absolutely right. They're geological time. And we have here, we keep coming down, we even have ones this low, and in fact, we are actually standing on some striations. Goes around here and comes back. That is actually a striation. So that's it for this Palo Duro Canyon video. I hope you enjoyed it. I hope you enjoy watching some of my other videos. What did you learn today? Well, we learned about erosion. We learned about a little bit about geology. A little about what the canyons are made of. A little bit more between Palo Duro Canyon and the Grand Canyon. And I just hope you enjoyed it all together. So until next time, stay wild.